Good morning, ladies and gentlemen. So today we have one interesting question which reads, let A be the set of all members except for one and star. So we know for sure that this is a special kind of zero which is always included in the study of binary operation in the replacement of star. So be the mapping from A by A to A, where we know for sure that A by A is simply a set of ordered pairs under functions, where we need to know that this set of ordered pairs at times follows a specific kind of condition. Defined by A star B be equal to A plus B minus AB for all A, B being members of A. So in this case, A is a set as they alluded in the preamble there. So prove that 0 is the identity element. So for you to prove that 0 is simply an identity element, we need to know one very fact. So we need to know that A star E is equal to E star A under the commutativity aspect of binary operation. So this is the same as A. So now that we have said that, we now need to understand the fact that since A is A and B has been replaced with E, remember E is what is referred to as the identity element in this case. So we just replace what we have in our original expression. So you have A star E, which is equal to A plus E minus A E. So this is what you have as your expression when you replace in that original expression over there. So you know for sure that A star E is the same as A, where we have A equal to A plus E minus A E. So from here we can say that we have common letters where A can go to join A and you have E minus A like that. So you know for sure that A minus A is equal to 0, equal to E minus AE. Then from here we will simply factorize. So we have 0 is equal to E, A minus A, where we will divide the both sides by 1 minus A for us to remain with the identity element E. So we know for sure that any number divided into 0 is still 0. That's why it is called an identity element, because the resulting outcome will always be 0. Then the very second question we have is for us to find the inverse of this particular function. So for you to be able to find the inverse, so this is what we basically do. So we will call our second question to be B. So what we do now here is A bar is the same as E, and A star A bar is the same as E under the inverse rule. But mostly we always use this for us to be able to prove the binary operation. So for some sort, this at times is always invalid. So from here we can say our A star A inverse equal to, remember, we are replacing this in the original expression, of which the original expression here is A plus B minus AB. So it will become A plus A bar minus A bar, of that kind there. So from here you know that A star A bar is the same as E, which is E, where E is the identity element, and you have A plus A bar minus A bar, where you know for sure that you can take this to the other side to become the identity element minus A equal to A bar minus A bar, where you know for sure that you can factorize A bar because A bar is common on both sides, and you have A bar open bracket 1 minus A. Then from here we will divide both sides by 1 minus A and this side by 1 minus A. So that can definitely cancel. So you have A bar being equal to E minus A over 1 minus A, where remember E is the identity element, and the identity element we are from solving, the value of it is basically 0. So A inverse is given by negative A over 1 minus A. So we have shown that the value of A being a member of A under the inverse has obeyed what we were given. So this is how basically you prove the identity element and solve for the inverse of a binary operation. Your host, Gordon Zulu.